Natural uranium contamination in major U.S. aquifers linked to nitrate. What's going on here? We're taking a look at ACS publications, and we can see groundwater geochemical data collected from two major U.S. aquifers, High Plains and Central Valley, revealed naturally occurring groundwater uranium exceeding the U.S. Environmental Protection Agency's maximum containment level, where 1.9 million people live. Analysis of the geochemical parameters revealed a moderately strong correlation between the U and nitrate, a common groundwater contaminant, as well as alkalinity and calcium. And nitrate is recognized to alter U solubility to oxidative dissolution of the reduced U IV minerals. Approximately 78 of the areas where the UI concentrations were interpolated above the MCL were correlated to the presence of nitrate, and shallow groundwater was determined to be the most susceptible co-contamination. Together, these results indicate that the nitrate, a primary contaminant, should be considered as a factor leading to secondary groundwater contamination, in addition to the recognized role of alkalinity and calcium. So, we're taking a look at environmental letters. What did they find? Uranium, U, containing of groundwater, has primarily been associated with anthropogenic activities, such as mining, milling, nuclear testing, and the disposal of spent nuclear fuel. However, groundwater concentrations across the United States exceed the U.S. EPA, the MCL, the maximum containment level of 30 grams per liter. And in many regions, including those without anthropogenic U activity, indicating source of a natural U contamination. And this is significant because the consumption of U contaminated water has been linked to neurotoxicity, osteotoxicity, and thus poses a health risk. In the High Plains, HP, and Central Valley aquifers are two of the largest and most productive aquifers in the world. And among the aquifers, the high concentration of dissolved U in groundwater, these are two aquifers that represent a common aquifer, unconsolidated sand and gravel composed of silt, sands, and poorly sorted clays, and gravel deposited through weathering and alluvium processes, and providing drinking water to 6 million people. In addition to an importance of source drinking water, these aquifers are also mined to irrigate 56,700 kilometers of cropland, accounting for 1/6 of all U.S. agricultural revenue. That is a huge amount. So drought has placed a resilience on the groundwater, impacting not only the quantity, but also the degradation of groundwater quality. And uranium is ubiquitous, naturally occurring radionuclide, common deposited as a diogenic secondary mineral in organic carbon-rich regions, and subsequent to weathering of ingenious pattern materials. The majority of U existent soils and sediments are insoluble reduced UIV minerals, U and nitrate, which may be associated with volcanic rocks, black shales, or orgonites, such as the general immobile or insoluble solvonic groundwater. For decades, it's been recognized that the exposed reduced UIV minerals to oxidizing groundwater leads to oxidative solution producing aqueous or dissolved U species, rendering U mobile at pH 6.1, will strongly be absorbed to sedimentary matrices. However, the mineral dissolution reactions will increase dissolved carbonate concentrations, favoring the formation of soluble carbonate species, and species absorption will become insignificant. So nitrate is the common groundwater contaminant, and primarily focusing on the surface applied chemical. The animal fertilizers also play a role in U solubilization, leading to the secondary U contamination. And biological nitrate reduction coupled to oxidation of organic matter can generally generate alkalinity mobilizing U. However, the generation of alkalinity alone cannot account for U solubility. If U originated as U mineral, then nitrate can abatically oxidize minerals, yielding aqueous and abatic and abiotic nitrate reduction will also produce reactive intermediaries such as nitrate and nitrous oxide will abatically oxidize. And we can see what's going on here with the concentration, and we can see the assembly of the metadatabase included the data points and the sampling data points here from aquifers as well, from coordinates, and it was assembled from groundwater sample data with reported numerical latitude, longitude, collection data, nitrate concentration or U concentration boundaries from HP and CV in the event of duplication groundwater sample report location on the same day in the nitrate or U concentration. So the issue here is that, simply put, uranium can cause a lot of problems in aquifers, and that can be potentially linked to nitrate. And these are two big problems. So it's always a good idea to periodically test your water, especially since they've done research like this and found some significant issues.